8.4 is on Z transformations. All right, so we've already calculated a Z-score before, but we've never used one. And the formula we used to find a Z-score several chapters ago was x minus mu over sigma. Okay? And so with what we were doing earlier in 8.3 with the standard normal distribution, the mean was 0 and the standard deviation is 1. Well, in all real-world situations, believe it or not, the mean is not always 0 and the standard deviation is not always 1. Very rarely. So if we want to use our Z-score chart the same way that we did in 8.4, then we just need a mean, a standard deviation, and then whatever data item we're looking at, and we can plug them into this formula and get a Z-score. We always round the Z-score to 2 places. Okay? So let's see how we could apply this to a problem like we were working. Now, the very first example that's given is a problem between. So it doesn't really start off with a super easy problem with less than or greater than. It starts off with a problem between, which is a little different, but we'll just go with it. Okay. So we're going to find the probability that a normal random variable with a mean of 10 and a standard deviation of 20 will lie between 10 and 40. Okay? So what we're going to have to do is these values here, the 10 and the 40, those are x values. All right? Our mean is equal to 10 and our standard deviation is equal to 20. So we need to find a Z-score for 10 and a Z-score for 40. So it doesn't matter what type of notation you use, but you may want to use a notation so that you can keep things separate. For example, I could write Z sub 10, and that would remind me that I'm finding the Z-score for 10. You don't have to do that, but if you want to stay organized, you might want to do that. Now, I don't always see it like that in textbooks, but if you're working with more than one value, sometimes it's good to notate so that you can keep things straight. So this would be equal to 10 minus 10. Well, that kind of makes this a little simpler. Over 20. 10 minus 10 is 0. So 0 divided by 20 is 0. So for x equals 10, we're going to have a Z-score of 0. All right. Now we need to find a Z-score for 40. So I'm just going to notate this Z sub 40 to keep me straight. That's equal to 40 minus, now remember you got to subtract the mean, so 40 minus 10 divided by 20. Alright, so that's going to be 30 divided by 20, or 1.5, which we could write as a Z-score is 1.50. Alright, so what I'm trying to figure out is the probability that my Z-score is between 0 and 1.50. Now that is the same thing as if I was to write the probability that my x value is greater than or equal to 10, less than or equal to 40. Both of these statements for this problem mean the same thing, because for a data item of 10, I have a z-score of 0, and for a data item of 40, I have a z-score of 1.5. Okay? So what I'm actually trying to figure out, you don't have to always draw a picture, but it might help you to understand what you're doing if you do draw a picture to begin with. Alright, so I have a z-score of 0 right here. I have a z-score of 1.5 probably somewhere about right here. And so I'm trying to figure out the area between the two. So if I find the area of the far right value in my table, and then I subtract the area of 0 to the left of 0 from my table, then that will give me the area between the two. Now, you could always just remember that at 0, the area is 0.5 up to that point, but you don't have to. We can use the tables. Alright, so if you look at your positive z-score chart, table C, alright, then we'll have for 1.50, we have an area of 0.9332. So 0.9332 is the area cumulative from left to right up to 1.50. Then if I subtract the area cumulative left to right up to 0, then that will give me the area between the two. And if you look at your z-score chart, this same chart at the very top, 0.00, you see you have 0.5000. So 0.5 is the same as 0.5000. So whatever that answer is, I guess it would be 0.4332. That is the probability that a normal random variable with a mean of 10 and a standard deviation of 20 will lie between 10 and 40. The next example in your book or your PowerPoint says find the probability that a normal random variable with a mean of 10 and a standard deviation of 20 will be greater than, that's important to this problem, be greater than 30. So 30 is our x value, the mean is 10, and the standard deviation is 20. That's the same as the previous problem. So we need to find a z-score. We're only finding one, so I don't think I'll get anything mixed up, so I'll just say z. So z equals, it's x minus mu over sigma. Alright, so that'll be 30 minus 10 over 20. So that's going to be 20 divided by 20. 20 divided by 20 is 1. So 1.00 is the z-score that I'm going to look at. Now, before I look the value up, remember what we're actually trying to figure out. This is my bell-shaped curve, and let's say I have a z of 1.00 right here. Since this says greater than, I'm trying to figure out the area to the right of 1.00. Alright, So to find the area to the right of 1.00, we can say 1 minus whatever value I get whenever I look in the table. Because the table is going to give me all of this area cumulative left to right. Okay, so this is 1 minus the probability from the table, or the area from the table. Alright, so let's look at the table for 1.00. I got 0.8413. So that's going to be 1 minus 0.8413, 0.1587. If you look in your book or you look at your PowerPoint and you look at this problem and you start looking at calculations, you can see they do it slightly different, but they get the same answer. It's just that the book is using table A, and it is also using symmetry. We are using table B and C, which personally to me makes more sense when you first learn this. Alright, so this problem says a soft drink machine outputs a mean of 27 ounces per cup. The machine's output is normally distributed with a standard deviation of 4 ounces. What is the probability of filling a cup between 21 and 31 ounces? Round your answer to 4 decimal places. Alright, so we have to identify what all these numbers mean. It tells us, the first sentence says that the mean of the machine, it fills up 27 ounces per cup. That's the mean. Alright. It also says that the standard deviation is 4 ounces. What is the probability of filling a cup between 21 and 31 ounces? Okay. I would think that the probability is probably going to be pretty high. Just trying to use common sense. But let's see. So what I need to do is I need to figure out a z-score for both 21 and 31. Okay, so I'm going to figure out, I'm going to denote this z-score z sub 21 just to kind of keep me straight. So this z-score is going to be 21 minus, so it's x minus mu, so 21 minus 27 divided by 4. Alright, and I want to round this z-score to 2 decimal places. So 21 minus 27 divided by 4. Negative 1.5. So I get a z-score of negative 1.50 for 21 ounces. So that would probably be about right here. I'm going to put that on my graph here, negative 1.50. Alright, now I want to find a z-score for 31 ounces. I'm going to name it z sub 31. That's 31, that's x minus mu, so minus 27, divided by sigma, 4. So 31 minus 27 divided by 4. That gave me an answer of 1. So that's 1.00. So that would be probably, if you had to guess, maybe about right here under the normal curve. So what I'm trying to figure out is the area between those two. Finding the area between those two will give me the probability of the machine filling a cup between 21 and 31 ounces. Alright, so what you want to do is look up the value for the far right z-score and then subtract the value for the far left z-score. Okay. Easy enough. So let's go to our table C, 1.00.8413. So 0.8413 minus, go to negative 1.50. Now, notice with the negative z-score chart, the way that this one is given, the first column is not the 0 for the hundredths. You have to go all the way to the right. So it's negative 1.5 and then all the way to the right. I got 0.0688. Is that right? 0.0688. Okay. So 0.8413 minus 0.0688 equals 0.7725. So what that actually means is there is a 77.25% chance that when the machine fills a cup, that the volume of the liquid will be between 21 and 31 ounces. It's kind of strange. You can use all these tables to figure that out. But you do have to know things like the mean of what the cup's volume will be and the standard deviation. In the real world, those numbers are sometimes the things that are hard to find or figure out or know. All right, let's look at one more problem. This is another homework problem. You'll probably see this one. The time spent waiting in line is approximately normally distributed. The mean waiting time is 5 minutes. So the mean equals 5. Now be careful on these problems because look what it gives us. It says the variance of the waiting time is 4. Now we don't need the variance in our z-score formula. We need the standard deviation, but that's okay. It just tells us that the variance is 4. So if I need the standard deviation, I just take the square root of the variance. The square root of 4 is 2. Okay, so in my formula, remember, I need x minus mu over sigma. Find the probability that a person will wait for more than 9 minutes. If the average waiting time is 5 minutes, then, I mean, it's probably not going to be a super large percentage chance, but let's see what the probability would be that a person will wait more than 9 minutes. I know I was at Walmart yesterday, which I hate, just because I just don't like to go in the stores, and I waited a lot more than 9 minutes when I was trying to check out. So, all right. So we need to figure out a z-score for 9 minutes. So our x is 9 here. So z equals 9 minus 5 divided by 2. Now see, if you divided by 4 mistakenly, then you would miss this problem. So you have to identify standard deviation, even if variance is given. So that's going to be 4 divided by 2, which is 2. So the z-score is 2.00. Now, were we wanting to know the probability less than 9 minutes or more than 9 minutes? That makes a difference. This says more than 9 minutes. More than is the same as greater than. Okay? So we want to know the area to the right because it says more than. So what I'm actually figuring out, if I had a z-score equal to 2.00, I'm looking for the area to the right of that. So what I'm going to do is I'm going to say 1 minus the area that's given in the table. So I need to use table C, go to 2.00, that's going to be 0.9772. Alright, so I have 1 minus 0.9772, 0.0228. Alright, and that's the answer rounded to 4 places. What does that answer actually mean? There's a 2.28% chance that if you went to this store that you would have to wait more than 9 minutes. That's a pretty small chance.